Welcome back. This is lesson 8 in our series on learning Python for beginners, and in this lesson you'll carry out some practice exercises. So there are no new Python skills here, but we'll apply the skills that we've learned. So in this lesson we'll briefly recap the Python skills that you've already learned. We'll go through a worked example applying those skills to solve a problem, and then I'll finish by giving you some further practice exercises to do. Let's briefly recap. The Python programs we've made so far use the IPO model. That is, we input some values from the user. We process or alter those values in some way, and then we output the result. Programming skills that you've learned fall under a number of categories. You've learned to create expressions, both numerical and string expressions, and use arithmetic operators. You've learned how to use the equal sign to assign a value to a variable using the form variable equals value. You've learned about the different data types and how to change the data type of a value. You've learned a number of different functions, and be aware that functions have parameters and return values. You've used input and output commands, and you've learned to make your programs user-friendly and readable. All of these skills will be used as we tackle the next problem. So this is the programming challenge that we're going to look at. We're going to create a program that lets the user input the dimensions of a room. That will be the height, width and length of the room. We're going to calculate the total wall area in square meters, and if we take it for granted that 1 litre of paint covers 12 square meters, we'll just assume that for now, and then we'll work out how many litres of paint we need to buy to paint the room. So when I plan a program, I use the IPO model. So first of all, I'm going to think about what are the inputs and what are the outputs. So the inputs are height and length of the room, and the width, or sometimes that's called the depth of the room. It's the short side of the room. And the outputs will be the amount of paint. The inputs are going to be in meters, and the output is going to be in litres. So how do we turn those inputs into that output? Well, we've got to calculate the total wall area, and then we've got to divide the area by 12 to get the amount of paint. Now, I've just left a question mark for how we calculate the total wall area. I'm sure you can work it out in your head right now, but I'm assuming that this is something we haven't thought of how to do. I'm going to show you how we can start a program even if we're not entirely sure about every step that's going to get us from the inputs to the outputs. We start blocking it out and we break the problem down into more manageable chunks so that we can get to the result we want. Here's my starter for the program. I've used comments. Remember, they start with a hashtag, and in idle, which is what we're using there, highlighted as red text, and the computer will simply ignore them. I often use comments to block out the structure of my program before I start writing the code, and that is a way that I can quickly build an outline of the program, and then later I'm going to come in and fill in the code to do those different things. So let's do that straight away. If you're following along at home, pause the video now, open Python if you haven't done so already, start a new program and create this structure as a set of comments. It's worth doing it just this once, just follow along exactly what I do, and then in the future exercises you can adapt this to your own needs. Okay, so let's look at the input part of the program. My comment was that I had to input height, length and depth, so I've created 3 input commands. I've paid attention to readability, I've used good identifiers as my variable names. I've paid attention to being user friendly because I've set out my work quite plainly and clearly with good prompts for the user, and I've even told them that they've got to enter a number in meters. And then I've converted the three variables into the float data type. The decision that I had to make there was whether to use float or integer, and there's no reason why a room should be a whole number of meters wide or tall. In fact, it's quite unlikely, so definitely need the float data type. Now I come to the part of the program where I have to calculate the area of the walls, and if you remember, I just left this bit as a question mark. So now I'm going to stop and think about what data I've got and how I'm going to work with it. So here's a little drawing of a room. A room's a cuboid in shape. It's got a height, a length and a depth, and it's got short walls, they're blue in this picture, and longer walls, they're yellow in this picture. And the yellow long wall is calculated as height times length, and the area of the short wall is height times depth. And if I think about it, there's two of each. There's two yellow walls and two blue walls. I'm just using blue and yellow to refer to the picture here. And then I have to add all of those numbers together. So that actually tells me what calculation I've got to do. So let's make that happen. I've devised two new variables called the long wall and the short wall. Long wall will store the area of one of the long walls, height times length, and short wall will store the area of height times depth. Then I'm assigning a value to the total area, which is 2 times the long wall plus 2 times the short wall. I just want to stop for a second here and talk about readability. I could have crammed all of that processing into one line of code. I didn't have to invent those extra variables called long wall and short wall. And in the final line, I don't actually need those brackets because the computer will do multiplication before addition anyway. So I made a few decisions there. I set the processing out over multiple lines, not in the most compact way that I could have done. And perhaps you'll understand that the reason I've done that is to make the program more readable. It's easier to understand what my processing is there. In this example, the processing is fairly straightforward anyway, but on the whole, I always err on the side of readability. I make my programs longer but more readable rather than squishing the code down and minimizing the amount of lines. That's partly because I'm a teacher and I want to show my students how the code works, but in general, I just think it is good practice. Oh yeah, and then I had to calculate the amount of paint, which is the area divided by 12. That's quite a straightforward calculation. And then the output section of the program, very easy. You need so many litres of paint, and that's readable and fairly straightforward. However, I decided to make it even more user-friendly by thinking about what my user, the painter of the room, really needed to see. And I changed the output section like this. I thought that paint always comes in cans of whole litres. So if a room is like 5.2 litres of paint, they're going to have to buy 6 litres of paint, aren't they? It's got to be rounded up because you can't buy a partial litre of paint and you don't want to run out before the end of the room. So this is what I did. I rounded the paint down. That is, I converted the float figure into an integer. That's not rounding up or down, it always rounds down. So if it was 5.9 litres of paint, turning that into an integer would turn it into 5. So it would go down and then add 1 to bring it up to the next whole number of litres. So that way I end up with just the right number of tins of paint that my user has to buy. I'm only going into all this detail to show you how thinking about the user. Remember I said that's how you make your program user friendly. Think about the user and what they're going to do. And thinking about it made me change my program quite a bit in the way I've just told you. I've also printed out the wall area because I thought the user might like to see that. And now my program is completed. Once I've created a program, I'll then enter some test data to make sure that my program is working properly. And I looked up online and found this picture of a typical medium-sized living room. And according to this site that I looked at, it's 5.5 meters long and 3.7 meters wide. And I also looked up the height of a typical room. And so the data I got was a typical height was 2.4, and then I used 5.5 and 3.7 from the previous picture, and ran that through the program, and I ended up needing 4 litres of paint. Now, it doesn't in a way matter whether that is accurate. That doesn't seem much paint to me, and perhaps you need more paint. Perhaps 1 litre of paint won't cover 12 square metres, but it doesn't really matter. I'm testing if my program works. And so what I did was I got a calculator. I actually used my online calculator, and I worked it all out by hand to see if I got the same result. And I did get the same result. So that made me conclude that my program was working okay. Though, as I say, I still have some doubts about whether a litre of paint will really cover 12 square metres. But in any case, my program is working fine. So take the time, if you haven't done so already, to pause this presentation and go back and build this program. And if you can think of ways to improve on it, that'll be fine. So this is my basic program. And then if you've got the whole thing working, here are some further extension activities that you can do to make the program even more useful. You can get the user to input how many coats of paint they want to put on, because that paint requirement was calculated assuming just a single coat of paint. Obviously, if you put 2 coats of paint, that's going to double the amount of paint that you need. You could allow your window to have 1 door and 1 window, let's say, and get the user to input the dimensions of those. They're not painted with the same paint as the wall, so you'd subtract that from the area of the room. However, doors and ceilings are painted, so you could add on a calculation of the amount of door and ceiling paint that you would need to complete the room. Let's assume they use different paint from the walls. And you could also calculate the floor covering. Let's say that would be a carpet or wooden floorboards or tiles, how big an area has to be covered. And then, so just from the room dimensions that you've entered, you could generate quite a lot of different information for the painter. Okay, so have a go at that. In the next lesson, we're going to start something new, which is the use of conditional structures. That's if, else, and so on, which will greatly expand the range of different programs that you can undertake. Okay, bye for now.